Hello everyone, I'm Prasad from Structural Guide. Today we are going to discuss about retaining wall failures. There are many types of failures in retaining walls. So when you do the construction of a retaining wall, we have to be very careful. We have to make sure it's not fail. So for that, you should know the method of failure. There are several failures I have listed here. So all those type of failures will be discussed today, and the method of overcoming these failures also will be discussed. Right, let's start our discussion. When it comes to the retaining walls, there are different types of retaining walls, and small retaining walls, large retaining walls are there. Mass concrete retaining walls, reinforced concrete retaining walls, gravity retaining walls like mass concrete, as I mentioned, are there. So basically we are going to discuss about all those type of retaining walls, basic type of failures, right? Most common type of failures we are going to discuss today. Right, let's start. Now when it comes to the retaining wall, we do a retaining wall to make the ground stable, or when you have a vertical cut somewhere in the ground. As you can see here, you need to have a vertical cut something like this. So you have earth here, so you want to make it stable, because vertical cut won't be stable without any structure. So we build a structure here to make it stable. So this structure is called the retaining wall. There are different type of retaining walls, right? So concrete retaining walls like this, or maybe it's maybe like this, and rubber retaining walls something like this, and there are many other type as well. So basically this type of retaining walls we use in construction to make the land stable, ground stable in this kind of a vertical cuts. So if we are telling the fundamental of this, now we have the soil pressure in this direction. This is P soil, and then you have a weight of the retaining wall, F say retaining wall. So all those are the two forces applied. This force may be soil, and also it may include the water pressure and surcharge load as well. So basically PS is the pressure or the force applied by the soil, water and surcharge. So the force on the retaining wall, and this is the force or the weight of the retaining wall. So when you have these two forces, it will rotate around this point, right? So it's rotating this point. Then how do you make sure it's stable? Now what is the overturning? Overturning means this soil pressure try to hold it down. So in these cases, so we have to make sure the overturning factor of safety 1.5. That's the requirement, basic requirement. So we maintain the factor of safety for overturning 1.5. What's the factor of safety? So we have a restoring moment. So when it rotate around this point, so we have a moment like this. Say this distance is x. So from this point to this point, say you have a height y. So the factor of safety we take and the restoring moment divided by the rotating or overturning moment. So restoring moment is Fr into x, and it should be divided by Ps into y. This is the overturning moment, this is the restoring moment. This factor of safety should apply, and this should be greater than 1.5, greater than or equal 1.5. This is the requirement. So if you have an earth pressure and you have restoring moment, so this has to be greater than 1.5. This is the criteria. So when you do any type of retaining wall, this has to be met. Now in this kind of retaining walls, as I mentioned here, the lever arm is bit different. You see, you have a soil pressure or the pressure on the retaining wall like this. The restoring moment or the weight from the retaining wall will be act like this somewhere here. Then additionally, soil pressure on this retaining wall will be applied here due to this extension to this side. So all those combinations will make the retaining wall stable. Compared to the first one, this is more stable because this part gets some additional weight from the soil to make it stable, but it's overturned about this point, but it makes stable, more stable by this soil. Even this is also this rubber retaining wall. It will overturn at around this point, but you see you can get the soil pressure, soil weight on these steps. Then it make more stable. In addition to this weight, these soil weights also make it stable. So though you have a soil pressure here, these additional weights make it stable. So that's are the things that we make the retaining wall stable, but more importantly, you have to make sure this factor of safety is greater than 1.5. Now let's move on to the sliding. In sliding also, we generally maintain a factor of safety of 1.5. What is sliding? Sliding is a very simple thing or very similar thing like as we discussed. Now you have a pressure on the retaining wall from the soil and other water surcharge etc. So you have to have a restoring moment from the other direction to avoid this force. Now you have a force on this. If you have a force like this, so it will be moving. So what are the forces? Base friction. So you have a friction in the base friction. So this base friction is there. In addition to that, you have a passive pressure here because you have a soil here. So this wall is resisted by this soil. Movement of the soil wall is resisted by this soil. So passive pressure is there. So you say passive force is there. So you have a PS here from the soil. So again, factor of safety for this one also should be greater than 1.5. So what's the factor of safety? So you have the resistance BF, you have resistance force, and this is a base friction, and you have a passive pressure. Then passive pressure, you can calculate the passive force. Say passive force is PF. So you have a resistance forces, then you have a soil and the other force on the retaining wall in the other direction. This should be also greater than 1.5 as we discussed. So you have to make sure this. You can't just build retaining walls. You have to make sure the stability requirement are met. Next point I am going to discuss is the bearing. So you know, when you have a soil, when you build the retaining wall on the soil, it will definitely be pressurized. Right? You have a soil over the process on this direction by the water and soil etc, and this weight will be there under the retaining wall, and also this due to the movement there will be certain stress. So if you take it symmetric one, it will be easy for me to explain. That's why I took the symmetric one. So you have a weight like this. So from the weight you have a uniform pressure on the soil, right? From the weight, then you have a soil pressure or PS here. So it will have a generate moment on this point. So then if you take the stresses around this point, so you have a tension stress here, you have a compression stress here, you have tension stress there, then you have a W, weight of the retaining wall also have a certain stress. So when you combine all these stresses under the base, you have a weight component and the soil pressure component, because this is try to rotate. Then you have a compression here, then you have a tension on the top, right? This, if you combine these two, so let's say this is minus, right? This also minus this, and then these two will be added, then these two will be deducted because this is in the opposite direction. Okay, this is 0 here, this is 0. So if this is in the opposite direction, so there may be like this. It might even go like this as well. In that case, it will be ended up here, something like this. It may be at like this also. There may be, depending on this force, this depending on these two values, this is these two values addition, it might be got 0 or minus. You can't get the minus force, and then it will be ended up somewhere there. So more importantly, then you have a here pressure, right? Here you have a certain pressure. This side it will be higher and this side will be smaller. So you know, bearing pressure, the soil has a allowable bearing pressure. So you should not exceed the allowable bearing pressure. When you do the design, you have to calculate the stresses like this, and you have to make sure the bearing pressure is not exceeded. This should not be greater than the allowable bearing pressure. It should be greater than or equal to the allowable bearing pressure. So that's also there. So we have to make sure it's not fail by the bearing. So not to fail bearing, you have to make sure this is met, or the applied pressure here less than the allowable bearing pressure, right? Now let's move to the next failure method, slip failures, right? Slip failure means, what do you mean by slip failure? Now when you have a retaining wall like this, right? So you have a soil soil here, so you have soil somewhere there, right? This is your retaining wall. Okay, let me do it complete one. Right. So soil can fail like this, is fail in wedges. So depending on the wedge arrangement, so this is the one it create the full pressure. So then you have considered the pressure here, then you have done the design, this is fine. But what happened here is this soil can fail like this, wedge can form like this, right? So then whatever the you design is doesn't make any sense, because this is within the wedge, though it's you have a factor of safety for sliding or turning more than 1.5, it doesn't make sense because this fail like this. So you have to make sure there won't be failure like this as well. So this one also we generally maintain a factor of safety of 1.5. So factor of safety is maintained around 1.5. These kind of failures it will be difficult to do it manually. You can use a software, then with that software you can find the factor of safety for these failure circles. So, okay, so minimum factor of safety you should check for this all curved lines. Sorry about this my drawing, but you have to make sure this is minimum factor of safety is met by 1.5, otherwise you have to do some modifications here. Now these kind of situations, to avoid these kind of failures, you might know the soil nailing. You can do soil nailing like this. Oh, as an alternative, building like structure like this, we do the soil nailing as well in most of the cases, especially in the road construction when we have unstable slopes. Rather building a retaining wall, which is really high cost to maintain, build a retaining wall like this, you have to spend a lot of money. For that, what you do is you do the soil nailing. This is an alternative method for this kind of failures, right? Let's move to the next or the last item that we are going to discuss. This is a structural failures. What is the structural failure? Now in a structural failures, now when you build a structure, now previous ones what we discussed are the stability requirement. When you build a structure, it should not fail structurally. That has to be stable structurally. What the structural things? Now when you have a retaining wall like this, you know we have forces in this retaining wall. So when there are forces, there will be bending moments and shear forces generated in this retaining wall. So maximum bending moment and shear force will be highest at will be here for the vertical wall. So we have a very high bending moment and the shear force here MNS. So you have to design for this. So you have to make sure there won't be failure here. You have to make sure you have provided adequate reinforcement there. In addition to that, there will be requirement of reinforcement in the base as well, or depending on the bending moment diagram. So you know there will be bending moment diagram, or bending moment will be there, the maximum bending moment here. So you have to provide the reinforcement. You have to make sure that deflection requirement are also made as a serviceability requirement. And for the base as well, you have to do the same thing. You have to do the reinforcement design, and you have to make sure the reinforcement are provided adequately. This is applicable for the reinforced concrete wall, but when it comes to the rubber retaining walls, you might need to take the stability requirement. In addition to that, you have to make sure there won't be any shear failures in the retaining wall, because when you have forces like this, there could be shear failures in these points. So you have to make sure there won't be any shear failures in these points. So therefore that has to be checked. In addition to the strength or tensile requirement, since this is the gravity type retaining wall, you won't allow it to develop the tensile stresses, but there will be diffusion stresses. So again, the shear failure is a kind of a tensile failure, so you have to make sure these kind of failures are not there when you do the designs. Right, these are the things that we are going to discuss today. So we today discuss about retaining wall failure stability requirement and structural requirement. Overturning, sliding, bearing, slip failures, all those were discussed as a stability requirement. And the structural failures we discussed structural requirement, basically the ultimate limit state reinforcement requirement you have to provide, and stability state you have to check the deflections of the retaining wall. So again, when it comes to the bearing also, you might consider as the serviceability requirement as well, but you can consider it as a stability requirement as well. So those are the things we discussed today. So let's meet again another video. Thank you very much for watching our videos.